Alright guys, this is Waleed, and today's problem from relativity is the age difference. So I'm gonna try explain it the best way I can. Okay, so let's see. So we have this physics instructor, and she's 19 years older than her student. And then she wanted to go on a spaceship and become 19 years younger than her student and decide to use special relativity to accomplish this. That's crazy. She jumps in a super rocket, travels away from Earth, period of 1 year as measured by her, so by the instructor. Okay, and then come back to Earth for the same period. So the teacher leaves for 2 years, okay, and then comes back. So she leaves Earth for 2 years. So let's just assume with numbers to make it easier. So let's say the teacher is 39 years old. Okay, so she leaves for 2 years, 1 year going, 1 year coming back. That means that her age is 2 plus 39, which is 41 years. Okay, and she wants to be 19-year older. When she comes back, she wants to be 19-year older than her student. Okay, so that means that she wants her student to be 41 plus 19, which is equal to 60. 60-year-old. This kind of makes sense. That's how much her student will be, should be, if she wants to be 19 years younger than her student. Okay, so if she was 39-year-old, the teacher, and the student is 19-year-old younger, as stated in the question, that means the student is 20-year-old. That makes sense. Okay, so that means that the student need to experience 40 years in her time, on her Earth time, okay, which is 60 minus 20. It's going to be equal to 40 years. Okay, that's on our time on Earth. The student is going to experience 40 years, and the teacher will only experience 2 years. So if we want to find the Lorentz constant, so we're gonna do T equal Lorentz times T teacher. Let's go T student. So T student is gonna be 40, and then T teacher will be 2. So the constant will be equal to 20. Okay. So going back to number 1, they're asking, ignoring brief of period of acceleration, what's the speed which the physics teacher is traveling during this time? Okay, so they want the speed at which the physics teacher is traveling during this time to accomplish being 19-year-old younger than her student. So what we're gonna do is, so the constant will be equal, I'm gonna call it like alpha to make it easier. So alpha will be equal to 1 minus v squared divided by c squared. Okay, and then we need to find this guy over here, the v. Okay, this is the speed that's going to accomplish this scenario that the teacher wants to be younger than her student. So doing some algebra, so 1 minus 1 all square root times c equal v squared. Okay, so we're gonna get 1 minus 1 divided by 20 squared divided by times c. Okay, this is to the power set. And then for this guy I got 0.9987 c. Okay, so for number 2, they asked us, in the teacher reference of frame, how does she travel away from Earth during the first portion of this period? Okay, so they want how far. So how far is delta x, distance is equal to time, delta time times speed, just v. So delta x will be equal to the time in the teacher reference of frame was 1 year in the first period times v. V is 0.9987 c. Okay, so for this we're gonna get 0.9987 light years. The light here, light means the c, and this was years, 1 year. Okay, so number 3, let's go up. Student reference of frame, how far does the teacher travel away from Earth during first portion period? Okay, so what we're gonna do is the total period was 40 years, right? Total period, as we agreed on it on here, 40 years was the total year that the student's going to experience. So half of that in the first portion is going to be 20 years what the student's going to experience. Okay, so we're going to do the same thing. Delta x will be equal to delta t times v. Okay, and delta t is 20 years, and the speed is going to be the same, which is 0.9987 c. And then for this guy I got, check what I got 19.97 light years. Cool. Alright guys, I hope this helped. This was a tough problem to get, but good luck, and if you have any question, let me know. Goodbye.